Hey everyone, welcome back to another stats class. Today we're going to look a lot at the normal distribution and, well, no, I'm getting ahead of myself. Today we're going to be looking at your Chapter 2 practice test, and naturally that's going to be a lot of normal curve stuff along with some other distributions, density curves in general, and of course with the normal curve we're talking about z scores. So let's take a look at that over here on your practice test. We're going to be looking mainly at questions 1 and 2 for this one. So question 1 says the weight of reports produced by a certain department has a normal distribution with a mean of 60 and a standard deviation of 12. So first thing to do is to take a look at what that curve looks like. Actually, let's keep reading this. It says that what's the probability that the next report will weigh less than 95 grams? So, like I said before, there is definitely a process here that we're going to hold on to. This process is going to be curve, z-score, and then answer. You got to really do all three of these. And remember, when I say curve, I really mean that kind of a double curve. So it's going to have the contextual data underneath it, the z-score data above it, and then that's both of them. So you're going to be jumping back and forth between the z-score and the double curve. So let's take a look at a standard normal curve. Here's our curve, and above it we're going to be writing the notation that tells us the part of the normal curve which is standardized, and that would be n parenthesis 0 comma 1. Notation means that this is a normal curve, the mean is 0, and the standard deviation is 1. Now that corresponds on the bottom with a normal curve where the mean is, well, let's just read. This says that the mean is 60 right over here. So we are putting n 60, and in that same sentence it also says the standard deviation is 12 right over here. So 60 and 12. So you're going to mark scores above and below this curve, starting with the mean. This one is a 0, and that corresponds to a weight of 60 grams. Now, across the bottom here, you could be writing weight of report in grams if you want to be a little bit more thorough about how you do this. Next thing I'm going to do is locate where would 45 grams be. Well, 45 grams would be below the mean, so somewhere in this area right over here, that's where 45 grams would be. Next, I would make a check to see if that 45 grams corresponds to one of the z-scores exactly. So I'm going to subtract 12 grams, so 60 minus 12, that's what, 48? And that would correspond with a z-score of negative 1. So 48 and negative 1. Well, clearly 45 is not going to fall on an actual whole number z-score. 45 would be just a little bit to the left of that. So this would be about 45 right here. Okay, and next we have to shade this. So what would be less than 45 grams? Well, less than 45 grams would correspond with all of this area to the left of that line. So you'll notice that we have 45 at the bottom here, but we don't have a corresponding z-score for that. So that brings us to the z-score calculations, which we'll do below here. So the correct z-score equation would be z-score is equal to any measurement or data, we'll call it x, minus the mean divided by the standard deviation. So for us, we have an unknown z-score, but we know everything else, so we'll substitute that in there. You've got 45 minus the mean of 60 and a standard deviation of 12. Do some quick calculations. And you get yourself a z-score of negative 1.25, which I'll put up over here, negative 1.25. So the z-score corresponds, a z-score of negative 1.25 corresponds with a report weight of 45. So that's our z-score calculation. Next, we're going to write some probabilities to complete our answer. So we're saying that the proportion of reports that are less than 45 grams is equivalent to the area in the z-score, that is z-curve, that's less than negative 1.25. Now I have no doubt that you all have your way of solving for this. Go to the internet, look for a normal calculator, but I'm going to go ahead and use the TI-84. And in the TI-84, we're going to go to second vars, which brings up our distribution menu. We're going to go to normal CDF, which stands for normal cumulative distribution function. That's a whole lot of words here. And we're going to do this 2 times. The first time we're going to do this in terms of the z-score. So the area, if we go back to our curve, our area, the lower bound of our area, doesn't really exist. It is far to the left, which would give us a very small negative number. Negative 1e99 is the smallest number that the TI-84 will give you. The upper bound is going to be negative 1.25. And if you go back to the curve, you can see that we're going this area goes all the way. Then once we get to a z-score of negative 1.25, we stop. So that's the upper bound of the area, or the right bound of the area. Since we're dealing in z-scores, we're going to go with 0 and 1, and then paste it, push and enter. So that gives us 0.1056. Now, in case you're not convinced, or in case that this was from a multiple choice test, you can probably bypass a lot of this and use that same calculator with the numbers in context. So in context, the smallest our report can weigh is 0 grams. Notice how it's already different than dealing with z-scores. The upper limit is one I actually forgot, 45 grams. So we'll put our 45 grams here. Our mean report had a weight of 60 grams and a standard deviation of 12 grams. So notice that this time everything is in context, and I mean every number here. The lower bound, the upper bound, the mean, and the standard deviation, everything is in context. So when I push paste now, I should get a number that's really close, and yeah, I would say those 2 numbers are very close. It's a good way of checking your work. So 0.1056, we get a 0.1056. This being stat, you're going to have to write a summary statement if this was something you did on a free response test. So here, the probability that the next report weighs less than 45 grams is 10.56%. Now, the question did ask specifically for a probability. I'll highlight that for you. So if it asks specifically for a probability, you better give it a probability as a percentage. So that takes care of our question 1. Problem 2 gives us a normal probability plot, and looking at the normal probability plot, we see that over on the left side of the curve, we've got a pretty tight cluster of data with a pretty steep slope here. But on the right side, we've got a set of data that is more spread apart. The slope is not quite as severe as the left side. So wherever you see the slope closer to zero, not quite, how do I say this? Not quite vertical, that's where we're going to get some skew. And I'm sorry, I should have read the question first, but the plot shown is a normal probability plot for a set of data. So the data is plotted on the x-axis and the standardized value. That's speak for z-score, by the way, standardized value. Is on the y-axis. So we're going to describe the shape here. So this is indicative of a right skewed curve. The first thing we notice is that the slope changed abruptly. So since it's the right side of that normal probability plot that has the more shallow slope, a slope closer to zero, we're going to say that the distribution is right skewed. So that kind of takes care of questions 1 and 2. Hopefully you've learned a little bit something here, and we'll see you for questions 3 and 4 in the next video.